Hi everybody, today let's learn about how to find the equations of a tangent and the equation of a normal of a curve at a point. Okay, now find the gradient of a tangent to the curve y equal to 3x squared plus 4x minus 2 at point -2, 2. Okay, if we want to find the gradient of the tangent, we need a gradient function. First derivative is a gradient function. So what we need to do is to differentiate this function. Y equal to 3x squared plus 4x minus 2 dy by dx is equal to 2 times 3. I hope that you still remember the process. 2 times 3, you will get 6. Copy the x. Power, you have to minus 1. 2 minus 1 will give you 1. Power 1, you don't have to write the 1. Differentiate the 4x here, you will get 4. Differentiate the constant, you get 0. Okay, so this is a gradient function. This is a function that we can use to find the gradient of the tangents to this curve. Since the question asks us to find the gradient of the tangent to this curve at this point, it means that we need to use these x coordinates at point -2, 2. What is the gradient of the tangent? Dy by dx is equal to 6x plus 4. Since the x is equal to -2, we just bring this -2 into this function, gradient functions. 6 times -2 plus 4. This will give you -12 plus 4. Okay, so -8. The gradient of this tangent is equal to -8. Okay, how about if this question asks you to do one more thing? It asks you to find the equations of this tangent. Always remember, if the questions ask you to find the equations of a straight line, you always look for two informations. First is a gradient of that straight line, and second is the coordinates of one point which lies on that straight line that you are going to find the equation for. Okay, since this is a tangent at this point, right? Definitely this point lies on this straight line. So we can use this point, this coordinates -2, 2, to help us to get the equations of this tangent. You can use this formula y equal to mx plus c, or y minus y1 equal to mx minus x1 to get the equation of the tangent. Both will give you the same answer. Okay, now I'm going to use this one. We have the gradient of the tangent, which is -8, and we have one point, -2, 2. Then no problem for us to find the equation of this tangent. At point -2, 2. Y minus y1 is equal to mx minus x1. Y, we just copy the y, minus y1. Y1 is this, 2. Is equal to m. M is the gradient of the tangent, which is equal to -8. X minus x1, which is equal to -2. Okay. Y minus 2 is equal to -8. Open up this parenthesis, it will become x. Negative will give you positive. Okay, let me write over here. Y minus 2 is equal to -8x. Negative positive will give you -16. Okay, so y is equal to -8x minus 16 plus 2. -8x minus 14. This is the equations of this tangent if the question asks you to find the equation of a tangent. Okay, now let's try a few more examples. given that the gradient of the tangent to this curve y equal to 3x plus x 8 over x at point P is equal to 1. The gradient of the tangents at point P is equal to 1. The question asks us to find the possible x coordinate of point P. Okay, this is a diagram. So normally if the question asks you to find the x coordinate of point P, for example in this situation, right, the questions will not provide you this diagram, because if you see this diagram, you already know that the x coordinate is 2 and negative 2, right? Okay, so I just drew this diagram for you to help you to understand easier to understand it, the situations mentioned by these questions. Okay, y is equal to 3x plus 8 over x. So I just change this to this form first. The questions tell you that the gradient of a tangent at point P is equal to 1. It means that the value of dy dx is equal to 1. We need to find the dy by dx. dy by dx. 3. Negative 1 times 8, you will get negative 8. Copy the x. Negative 1 minus 1, you get negative 2. Now I'm going to change back to this form. Okay, so these are gradient functions. This is the function that we can use to find the gradient of the tangent. Since the question tells you that at point P, the gradient of the tangent is 1, right? It means that the dy dx is equal to 1. When dy by dx is equal to 1, this is equal to 1. 3 minus 8 over x squared is equal to 1. The question asks us to find the possible value of x coordinate. Means that we need to find the value of x here. Okay, so here I just bring the negative 8 over x squared over here, and the y go over here. I just change their places. 3 minus 1. Okay, this bring over here, it become positive. Okay, so this will give you 2. 2 is equal to 8 over x squared. X squared bring up here, and 2 I bring down. You will get this. Okay, x squared x 8 over 2. Okay, so x squared is equal to 4. We are looking for the x coordinates. We have to square root it. Okay, now we square root it, right? So we have to write plus minus. Okay, the answer, the possible x coordinate is positive 2 and negative 2. You can get it from this diagram, you see. At this point, at this point, the gradient is equal to 1. Okay. Let's try another example. Find the equations of a tangent. Okay, now we are going to find the equation of a tangent to this curve that is parallel to the straight line y equal to 2x minus 5. So remember what I told you just now. If you are asked to find the equation of a straight line, tangent is a straight line, we need two informations. We need the gradient and also 1 point, right? So now we already got the gradient, which is 2. Y is equal to, okay, let me write over here. Y is equal to 2x squared plus 4x minus 3. We want to find the equations of a tangent which has a gradient of 2. Because the question tells you the gradients of the tangents parallel to this straight line. It means that they have the same gradient, right? So we already got the gradient here, which is equal to 2. But we still need 1 point. So how do we get the point? First, we find the dy dx first. dy by dx. So this is 2 times 2, you will get 4x. 2 minus 1, you will get 1. You don't have to write 1 over here. Differentiate 4x, you will get 4. Okay, now this is the gradient functions. We know that the gradient of the tangent is equal to 2, right? It means that this value is equal to 2. From here, we can get the x coordinate. When dy by dx is equal to 2, it means that 4x plus 4 is equal to 2. 4x is equal to 2 minus 4, which will give you negative 2. X is equal to negative 2 divided by 4. X is equal to negative 1 over 2. Okay, now we have the x coordinates. How do we get the y coordinates? Can we take this x coordinates sub into this equation? No, we cannot. Because now we are going to find a point which lies on the tangent. We cannot use this equation. We need to use this function. So what we need to do is bring the negative 1 over 2, substitute into these functions to help us to get the y coordinates. When x is equal to negative 1 over 2, y is equal to 2 times negative 1 over 2 square plus 4 negative 1 over 2 minus 3 minus 3. Okay, you just press your calculator. 2 square plus 4 times minus 3. Negative 9 over 2. Okay, now we got the information for the this. Negative 1 over 2, negative 9 over 2. Now we have the coordinate of one point which lies on that tangent, and we have the gradient of the tangents, right? So we have no problem to find the equations of the tangent. At point, this point, negative 1 over 2, negative 9 over 2. I am going to use the formula y minus y1 is equal to mx minus x1. You can try to use y equal to mx plus c. You will get the same answer as well. Okay, now y minus y1 is equal to m, the gradient of the tangent, which is equal to 2. X minus x1. Okay, let me write over here. Negative will give you positive. This negative, you get positive as well. Okay, so we just expand this, expand up this part. 2 times x, you will get 2x. 2 times 1 over 2, you will get positive 1. Okay, so y is equal to 2x plus 1 minus 9 over 2. Negative 7 over 2. Okay, so this is the equations of this tangent. If you don't want to stop here, you actually can proceed one more step if you want. If you don't want to see a fraction here, you just times 2 for times 2 this whole equations. You will get 2y. Here you get 2y. This you will get 4x, and here you get negative 7. These both answers are correct. Okay, now let's try an example here. Find the equations of the normal. This time we are going to find the equation of the normal, but not the equations of tangent. Equation of the normal to this curve at point 1, negative 2. Okay, this is 1, negative 2. Now we are going to find the normal here. This is a tangent. This is a tangent, and this is normal. Okay, so just now we find the equation of a tangent, right? Now we are going to learn how to find the equation of the normal. This normal is a straight line as well. So still the same thing. If you want to find these equations, we need two information. Gradient, 1 point. So you will notice that the tangents and the normal, right? They are passing through the same point, which is here. Okay, so I need to find the gradients of this normal. Y equal to 3x squared plus 4x minus 9. How do we find the gradient of this normal? We know that the normal and the tangents, they are perpendicular to each other, means that they intersect at a 90 degree here. If they are perpendicular to each other, I hope that you still remember the products of their gradients, m1 times m2, will give you -1. You learned before in Form 4. I hope that you still remember this. It means that if we have the gradient of the tangents, then we can use this relationship to help us to get the gradient of the normal, right? Okay, now let's get the gradient function first. dy by dx is equal to 2 times 3, you get 6x. 2 minus 1, you get 1. You don't have to write 1. Differentiate this, you get 4. Differentiate a constant, you get 0. Now this is the gradient functions. These are functions to help us to get the gradient of the tangent, not normal. This is a tangent. At this point, we want to find the gradient of the tangent first. At point 1, -2, dy by dx, which is a gradient of the tangents at this point. 6, we are going to use, we only use the x coordinates. Substitute the x coordinate of this point into these functions. 6 times 1 plus 4. Okay, you will get 10. It means that the gradient of this tangent here, gradient of tangent, is equal to 10. Then, can we get the gradient of the normal? Yes, by using this relationship. Gradient of tangent times gradient of normal. In the exam, you don't have to write so long. You can just write m1 times m2 is equal to -1. Okay, now we know the gradient of the tangent. The gradient of this tangent is equal to 10 times gradient of normal is equal to -1 because they are perpendicular to each other. So the gradient of normal is equal to -1 over 10. Now we have the gradient of normal, which is equal to -1 over 10. Okay, now we have had all the information that we need for finding the equation of a straight line. We have the gradients and we have 1 point, right? So we can start to find the equations of the normal. Y minus y1 is equal to m x minus x1 at point 1, -2. At point 1, -2. Okay, I'm going to substitute all the information that I have here into these equations. Y minus y1 is equal to m. This is a gradient of normal, not gradient of tangent, because the question asks us to find the equation of the normal. So definitely we need to use the gradient of the normal, but not the gradient of the tangent. Okay, so m is equal to -1 over 10 x minus x1, which is equal to 1. Okay, so negative, you get positive. This, we just do some expansion over here. -1 over 10x, negative will give you positive. Okay, this expansion, I hope that you still remember. If I'm not mistaken, you learn in Form 2. So you remember? Negative, you get positive. Okay. So we try to simplify it further, make it nicer. y is equal to negative 1 over 10x plus 1 over 10 minus 2. Okay, let me check. 1 over 10 minus 2. Y is equal to negative 1 over 10x minus 19 over 10. So you can stop here as your final answer. If you don't like to see a fraction, you can do one more step just by multiplying the whole equation by 10 so that you can get rid of this denominator. You will get 10y negative x negative 19. Okay. So for this video I stop here first. So hope that you understand better how to find the equation of a tangent and how to find the equation of the normal. Always remember, if you are asked to find the equation of a straight line, always look for two informations: gradient, 1 point. The point that you use must lies on that straight line that you are going to find the equation for. Okay? So see you next time. Thanks for watching. Bye bye.